Hi, my name is Bryant and I'm a development engineer for Texas Multicore Technologies. In this video, I will be walking you through the basics of writing and compiling programs using SequenceL. This video assumes that you already have SequenceL installed on your computer. If you do not, you can see the previous video in this series on how to do that. Let's start with an overview of the standard SequenceL development workflow. SequenceL is a purely functional declarative language and as such has no built-in I/O. The SequenceL developer must link their SequenceL code with a C++ driver in order to make a complete application. When making a standard SequenceL application, the developer first writes their SequenceL code. This is where the computational bulk of the application resides. That code is then compiled using the SequenceL compiler into parallel C++ code. The developer then writes a C++ driver which handles the input and output for the application. Finally, the C++ driver and compiled SequenceL code are linked using a C++ compiler into the final executable. So the two key parts of a SequenceL application are the SequenceL code and the C++ driver code. So let's go ahead and get started. Today I will be using the SequenceL plugin for Eclipse for this demonstration. To get started, I will make a new SequenceL project. The program I'm writing today will be a simple Fibonacci number calculator, so I'll call it Fibonacci, and I will be using the Visual Studio C++ compiler. Once that's created, you can see that Eclipse automatically generates the two key parts of a SequenceL application, a SequenceL file, main.sl, and a C++ driver file, main.driver.cpp. I'll start by filling in my SequenceL code for Fibonacci. This is a very naive recursive implementation of Fibonacci. If this is your first time seeing SequenceL code, there are a few things you should notice. First, you'll notice that there is no return type specified for the function Fibonacci, and no type specified on the input argument in. This is because SequenceL is an inferred type language. The return types of functions and the types of input arguments are automatically inferred based on their usage. You'll also notice that there is a parenthesized 0 after the input argument in. This specifies the dimension of in, 0 meaning that n is expected to be a scalar. So the intuitive reading of this function is, the nth Fibonacci number is in when n is less than or equal to 1, otherwise it is the sum of the n minus first and n minus second Fibonacci numbers. Alright, now we can run this program in the SequenceL interpreter to verify correctness before compiling it. I'll try Fibonacci of 2, 3, 4, 5, 6, and 7. Those all seem to be correct, so we can go ahead and compile the SequenceL code. In order to compile SequenceL code, we must provide the SequenceL compiler with an intended use. This specifies what functions we would like to compile and provides types for the input arguments of the entry point functions. To set the intended use, I'll bring up the project properties. And in the intended use box, I'll type Fibonacci of a scalar integer. We can also specify the output name of the C++ files, but I'll leave that as main. I can now right-click on the project and build the project. The SequenceL compilation will succeed, however the C++ compile will fail because we haven't updated the C++ driver code to call our new SequenceL function. Now you can see in the Project Explorer that there are two new files, main.cpp and main.h. These are the output of the SequenceL compiler. Now we will write the C++ driver. You'll notice that the default driver is calling sl_hello. This is because compiled SequenceL functions are prefaced with sl_. We're already including the generated main.h file, so we have access to our generated Fibonacci function. So I'll change sl_hello to sl_Fibonacci. The last two input arguments to a compiled SequenceL function are always the number of cores we would like to run on and the result destination. All of the function inputs come first. So, to test, we'll start with finding the 8th Fibonacci number, and the result is going to be an integer. We also need to call the SequenceL runtime initialization and cleanup functions here, slinit and sldone. The only argument to slinit is how many cores we would like to run on. Here we will be using 0 cores to indicate that we would like the SequenceL runtime to automatically use all cores available. Now we'll build the project again, and this time the entire compilation should succeed. Once compilation is finished, we can navigate to our project folder and run Fibonacci.exe. That looks correct, so now let's have our driver handle some input and improve its output, again because that is the primary function of the C++ driver. We can start by reading the input to Fibonacci off of the command line. We can also better format the output of our program. Now we'll go ahead and build our project again. And now when we execute our program, we can actually specify which Fibonacci number to find at runtime. So what I've shown today is the standard workflow necessary to create an application using SequenceL. In the next video, we will explore some more advanced SequenceL development topics. Thank you for taking the time to watch this video. If you have any questions or comments, as always, feel free to comment on this video or contact us via our website, which is linked to in the video description. If you're interested in learning more about SequenceL, be sure to subscribe to this channel.